This is the main time we get to circle Mercury, situated at the very front of the decreasing region of our solar system. Mercury, a small uninhabited planet, lies enclosed by a web of mystery and interest. At first glance, nothing seems particularly extraordinary about this planet. However, recent examinations by NASA have uncovered some surprising discoveries about Mercury that no one anticipated. These marvelous revelations, combined with records from the James Webb Space Telescope, JWST, have sparked discussions in the scientific community. Some speculate about the possibility of ultramodern extraterrestrial species hiding within the planet. Amid the turbulent discoveries and odd conspiracy theories, a new plan is emerging within the scientific community. This plan aims to strip away Mercury's veil of mystery and uncover its dark secrets and strategies. What mind-blowing secrets and procedures might be hidden around Mercury, and what current plans does the scientific community have for this mysterious cosmic neighbor? Be sure to follow this video, as the JWST eventually reveals what NASA has been concealing on Mercury all along. Our solar system is more than just an inherent framework of state-of-the-art planets orbiting the Sun. Each of the 8 planets in this enigmatic ring system has unique characteristics and contemporary features. While planets like Jupiter and Mars might have taken the spotlight with their awe-inspiring significance, Mercury is an intriguing planetary body often overlooked. Mercury is the closest planet to the Sun, with a distance of only 58 million kilometers compared to Earth's 150 million kilometers. It is also very small compared to Earth, measuring just 3,000 kilometers in diameter. Due to its tiny orbit around the Sun, Mercury is the fastest planet, completing its revolution at an incredible speed of 47 kilometers per second. This means a year on Mercury is only 88 Earth days. Mercury's short period and high speed are just a few of its dazzling capabilities. From a distance, Mercury might appear to be a habitable planet. The small planet has always fascinated the scientific community, but for some reason, it hasn't garnered as much interest as its more prominent cosmic counterparts. The first recorded observation of Mercury was in 265 BC by early astronomers like Xu. In 39 BC, additional studies of the planet were conducted, but all the scientific community had at that time were fragmented data due to inadequate scientific equipment and old telescopes. It wasn't until the 1960s that genuine knowledge about Mercury came to light, thanks to the efforts of NASA. A few years ago, NASA revealed the first true photograph of Mercury to the public. These larger-than-life images confirmed Mercury as a divine embodiment of state-of-the-art beauty and complexity. However, this revelation didn't come easily. Despite meticulous plans and developed attempts to understand Mercury, researchers could only observe it intermittently. Researchers struggle to study Mercury as they do other planets due to its proximity to the Sun. The Sun's harsh rays and brilliant light can damage optical instruments like telescopes when they observe Mercury for too long. As a result, scientists can only study Mercury for brief moments to avoid damaging their equipment. Even the JWST cannot point directly at Mercury due to its closeness to the Sun. It is puzzling how this particularly small, nearby planet is harder to study than the more distant planets. The temperature and gravitational pull from the Sun make sending a probe to Mercury more like a suicide mission than a celestial challenge. The probe must adapt to the temperature, environment, and gravitational pull, otherwise, it will fail. It might surprise you to know that Mercury travels around the Sun at a whopping speed of 30 kilometers per second. This breakneck speed makes it the fastest orbiting planet in our solar system. This speed also poses a challenge for spacecraft that aim to study or land on the planet. So far, only a few space missions have targeted Mercury. The Mariner 10, launched on November 3, 1973, and the Messenger, launched on August 3, 2004, were both developed by NASA. These missions are the primary sources of almost all the information we have about Mercury today. The Mariner 10 spacecraft performed 3 flybys, each revealing the crater-filled surface of Mercury and shedding light on its intriguing region. The spacecraft was equipped with telescopes, spectrometers, a magnetometer, and a plasma analyzer, allowing NASA to gather as much data as possible from Mariner's visit to Mercury. As the probe approached Mercury, scientists were amazed to see the planet's tumultuous surface, which was riddled with craters and ridges similar to our Moon. The photos from Mariner were astonishing, revealing Mercury as something completely different from what experts had expected. Besides the rugged planetary surface, the probe also detected an inclined magnetic field and an enormously large core. Overall, Mariner 10 captured 2,700 pictures of Mercury, providing scientists with a unique and astounding view of the planet's captivating landscape. The second flyby of Mariner 10 took place on September 21, 1974, during which it captured images of the southern polar region of Mercury. The final flyby occurred on March 16, 1975, after which the spacecraft stopped sending signals to Earth. Later examinations found that the probe had exhausted its fuel supply and could no longer make additional rounds. The spectacular achievements of Mariner 10 were succeeded 30 years later when NASA's Messenger took on the task of studying Mercury. Unlike its predecessor, Messenger didn't perform flybys but instead orbited the planet. This allowed scientists to gather more comprehensive and intriguing data about the planet. Equipped with state-of-the-art imaging technology, NASA sought deeper insights with this mission. This time, it wasn't just about images. The agency wanted to understand more about the planet's environmental conditions, chemical composition, magnetic field, geological history, and planetary core. Messenger made 3 orbits around Mercury, taking approximately 200,000 pictures of the planet. These images were crucial because, unlike the Mariner mission, they highlighted every side of the planet. During the Messenger mission, the probe managed to enter the planet's orbit, flying at about 250 kilometers above the planet's surface. This proximity allowed the probe to capture images of both the light and dark sides of Mercury. After analyzing the pictures and comparing them with data from the spacecraft, scientists determined that our neighboring planet had unusually high concentrations of calcium. Additionally, the planet's magnetic field appeared abnormally distorted, being stronger in the northern regions. This odd pattern puzzled researchers for years until in-depth studies revealed the cause. Mercury's unique and unprecedented magnetic field sheds light on the planet's internal structure. Magnetic fields on planets are generated from the reactions occurring in their cores. Take Earth, for example. The innermost part of Earth's core is composed of liquid iron, but as it cools and solidifies, it interacts with the surrounding liquid iron. This interaction, combined with Earth's rotation, creates a strong magnetic field extending into space. This is the true mode of action for Earth and how its magnetic field lines are generated. Similarly, Mercury's magnetic field suggests that iron is snowing within its core, fueling its magnetic field. Studies have shown that exploration of Mercury has become customary, with significant records from NASA's Messenger mission. The overwhelming discovery led researchers to believe that planets have more than one way of generating an attractive field. Even though Mercury and Earth comprise similar components like sulfur and iron, specific variations between these two planets result in notable differences in their magnetic fields. The disparity between Earth and Mercury extends beyond their magnetic fields. For instance, researchers found that temperatures on Mercury can rise above 430 degrees Celsius during the day and drop to as low as -70 degrees Celsius at night. This extreme temperature fluctuation is attributed to Mercury's lack of a substantial atmosphere. Unlike Earth, Mercury has a thin exosphere, primarily formed by atoms ejected from its surface by meteoroid impacts and solar winds. Scientists believe that Mercury's proximity to the Sun causes any potential atmosphere to dissipate quickly into space. Furthermore, Mercury's day is twice as long as its year. One full day on Mercury equals 176 Earth days, while its year is 88 Earth days. This prolonged exposure to intense heat and daylight, followed by extended periods of cold, contributes to the planet's severe temperature variations. The fascinating temperatures on Mercury have led to speculation within the scientific community about the possibility of life. While the extreme conditions make life seem improbable, some believe that if we dig deep enough, we might find life forms. NASA's Messenger mission mapped Mercury's surface, revealing its craters and geological features. The planet's composition includes 46% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium, along with a surprising amount of sulfur and low iron content. This unique composition distinguishes Mercury from other planets in the solar system. Mercury also has a thin, dusty ring around it, surprising many researchers given the planet's small size. Typically, only larger planets like Jupiter and Saturn have rings. Scientists speculate that Mercury's ring may have formed from meteoroid impacts. The continuous bombardment of Mercury's surface by meteoroids and other space objects could have created the ring of debris. Despite its small size, Mercury's geological activity and composition continue to intrigue scientists, who speculate about the planet's formation and its potential to host life under its harsh conditions.